Hello, Maurieo. Maurieo reviews Land Surveying 1 2017 Levelling Test. Hello. In this video I'm just going to run through the model answers for this test that we've had just a week or so ago, and go through a few of the tips and traps, some observations at what I had from after having marked the test, and some of the problems and errors that people made, and the help that every learning opportunity should be taken, and the test is one of the best learning opportunities, particularly if we review our performance after the test. If we just sit the test, look at the mark, forget it and carry on, it's a wasted opportunity. So take the time to have a look at your test, go through, see where you went wrong, make sure that you won't make that mistake again, and that'll stand you in good stead for the end of year examination, which is coming up, and we'll have similar questions. So let's go to the big screen. Let's go to the big screen here and see if we can find the test. So we'll get out of the PowerPoint there and we'll go to the NZDE test. So here's the model answers. These model answers are available on Moodle there, so you can view these and have a go through them yourself. So that should be the first page there. Stu Ideal, the ideal student, of course. So let's go there and page down for the first question. So what is the purpose of the staff bubble? Well, it's to keep the staff vertical for reading. Now, there was a number of things here, but quite a lot of people made the mistake of saying it kept the staff horizontal, which would actually make it impossible to read. So remember to check these things. Sometimes when you think, now that's right, isn't it? You're actually putting the opposite to what you actually mean. So vertical, straight up and down; horizontal, parallel to the earth or level. So to keep the staff vertical for reading, or truly vertical. Some of you used the word level. I wasn't too happy with that. I would have preferred vertical. So bit of variation around that. Now this next question 2, label the diagram. So label it clearly. Your back sight, the staff, foresight. Line of collimation is the line that goes through the level. That's the level line, the line of collimation. These here are the marks that you get. The difference in height is the difference between A and B. Now most people got the difference at height of 0.933, apart from those who could not subtract and seem to get all sorts of variations on that. But that can be done on the calculator, and certainly it's always the back sight minus the foresight will give you the difference in height between A and B, and that's it in there. So most people got that correct. Where a lot of people went wrong is getting the RL of B, and the RL of B, of course, is you use the difference in height, the rise and fall. A lot of people used this number here, 0.823, for some reason, but no, it's 18.592, the RL of that, plus or minus the difference in height. In this case it was a rise. So yeah, that's what the rise or fall, that's what it means. So when planning to level through a busy pedestrian area, the most obvious hazard is pedestrians, people. So this would be like maybe leveling through a shopping mall, or perhaps across a busy campus, sort of like through the area, say between G Block and the cafeteria in there, with a lot of people walking around. So there's many ways of managing the hazard, and I did accept a number of different answers. The best one I would probably do is come back at night when no one is there. Now the hazard itself hasn't gone around. There still could be the odd person there, but not as many. So that sort of minimises the problem. It doesn't eliminate it, because pedestrians can still work through, unless of course you have total lockdown. And isolate, well, Not really, again, unless you put barriers and that up. So there's a lot of different ones there, but my feeling was you go for, what's going to be the best for the situation. A few people did say this come back when there was more time. Most people sort of went for a barrier type thing, which is fine, and that's an isolate issue there. So remember the three things: eliminate, isolate, minimize. Okay, the next question, just reading these staves. I think the biggest problem I got with these was people asking me, how close they had to be. So plus or minus a couple of millimeters, as long as you're pretty much in the zone. But yeah, most people got these pretty good. But there was some that, totally out of the ballpark. The upside down staff is a negative. Now, the way this question is describe a scenario where an inverted staff is used as pictured, so inverted. So to measure the height of the eaves or the roof of a tunnel or something like that, of eaves of a building or something like that, where you've got I think a lot of people came up with some better answers actually than mine, where something essentially is above the line of collimation of the staff, of the line of collimation for the setup there. So but most people got that, and parallax question was answered pretty well. Yeah, parallax, that's the name of that problem. So that brings us to the little leveling thing here. I think it's pretty self-explanatory that, you have to know how to do this and how to do it, and you need to teach it. If you had problems with this, you need to work it out and teach yourself how to do it. It's very methodic. There's a method that you follow. So you take your back sight, and then it's the next one, the one below it and to the right. Okay, below and to the right. So there you go, below and to the right, 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 and then back here, below there, and it's, below and to the right. Here it's below and to the right, here it's below, and there's one directly below, and then below and to the right, and below and to the right, like that. There was a problem here with the negative. Maybe 6 or 7 or 8 people didn't see the negative there and got that one wrong there. I remember that when you're dealing with intermediates, it'll only affect the intermediate shot itself. The other level values stay the same. Getting these additions, you should know what you have to do there. So it's adding that, adding the rises, adding the fall. The difference between the two should be exactly the same. If it's not, if this here is not the same in this case, or they're not equal to 0, if you're doing a loop traverse, something is wrong with your arithmetic, because these values here generate these values here, so they should there. Now, if they're not, you keep going until they are. Find the problem, because if you carry that problem through, it's just going to make bigger problems for you. So this here, once you've got that, this should come in here, should be fine. Okay, 3 marks for getting that all sort of right, and then it's got a 4mm misclose, applying the misclose 2 marks, and then getting your final results 1. Now, there was some big problems with this question here, because people thought that it was the same as the 2016 test and the 2015 and the 2014, and maybe even the 2013. But if you read this question carefully, you will see that an often quoted standard for third order blah blah blah. Under this standard, what is the allowable misclose for a 2,500 meter leveling run? Now, what I tried to do here is, rather than use this one here, so if you say you got the misclose incorrect here, then it would impact on this question here, I introduced it so that it was a totally new question. So the answer, you should have used 2.5, and a majority of people did, but some people Some people didn't. Some people used the 300, and some people, yeah. Now, this next question here, some of you actually totally ignored the question and just wrote the answer to the question from 2016, which was related to how good this misclosed hair was in relation to that. So this here relates to the worksheet that we did, where you should on the plan show, in my opinion, the datum, what datum you're using, Maurieo datum. So levels are in terms of Maurieo datum, and the origin of heights, you should state what your origin of heights is. So in this case it was BM FD DP 406723 RL 62.372. Now I've got a number of variations on that, but you do need to have something that's sort of coherent and makes sense and something along those lines. So a bit of variation in that question there. And that brings us to the last question here for the NZDE. So the gradient question. Generally the first one was quite well done. What is the, generally well done. What is the gradient between that and that? So rise over run. Now what I've done is I've gone minus, I went minus that one, minus the first one plus the second one, because that's just how I did it. So that's and that's 560 minus 340 for the run. So the rise is it's going from 106.42 down to 92.08. So that's actually, it's falling, which would be negative. So you would expect it to be negative. So yeah, it should have a sign there, and the gradient percent minus 5.975. So as long as you got the percentage there, I was just thinking now perhaps I wasn't quite that stringent on and harsh on in looking in to see if it had a sign. But 5.975 is the gradient, and it's falling. Now this is where a lot of people fell apart. At what change will the centerline level be 100? At what change? So a lot of people got confused because of it being a negative, and so it starts at 106.42, and this is where it would have perhaps been a good idea to draw a diagram so that you could, diagram to sort of, with a bit of scale to it, so that you can actually see what's happening. So you can see that it starts at 106.42, so it needs to fall 6.42 meters, minus 6.42 meters. Now you've got up the top there, gradient equals rise over run. So rearranging the formula, you'll get run equals run times gradient equals rise, and so rise equals run over gradient there. So you've got minus 6.42. Now remember that the gradient is expressed in a percentage, so the actual gradient is not minus 5, it's minus 0.05975. So remember, you want the gradient, not the percentage gradient. And that tells you that it'll drop 6.42 meters in 107.447. So if you add the 107.447 to the start chainage, 340, that'll give you 447.4477 or 447.45. Now, some people didn't. I would definitely go to 2 decimal places, possibly even 3 with these chainages, which is quite common. But some of you just went to 447, and I didn't think that was enough. You need to go to 2 or 3 decimal places is acceptable. So yeah, I just cut it off at 2 decimal places here, but certainly not to the nearest meter for the chainage. So yeah, I did take maybe half a mark off some of you for that. Now this, in the Bachelor of Engineering Technology, the last question is slightly different. We have to have a different things. So the first bit's the same, but the second one is a bit trickier. It is proposed to continue the road at the same gradient for another 160 metres. What would the centreline level of the proposed road at change 700 be? So you're going from 700 to 340, and that's actually 340. 700 minus 340 is 360. Okay, and the gradient's that. So the rise over 360 metres would be 360 times negative, which is minus 21.51. So the RL at change 700 would be 106.42 minus 21.51, which is 84.91. So yeah, generally I think that question was done all right, although some people were able to work out the 21.50, but applied it as a positive rather than a negative. So yeah, little things there. I do say, and I haven't done it myself, that probably a good idea to draw a diagram, draw it on the diagram, and then work with that. So there you go. That's our review of the test. I've gone through it, few little tips and things there where people went wrong. I've done that so that for next time, you've got some ideas. So you make sure that you sort out the areas where you have problems. Perhaps print off a blank copy of the test, make sure you can do it, because these questions, while not exactly these questions, but these questions and similar, will appear in the end of the year exam. So that's it from me. Cheers. See you.